In this episode, we're beginning to integrate our gameplay ability system in with our AI adversary character. Hey guys, this is the first episode where we're really starting to think about how a realistic AI opponent should actually act. And our goal with this initial gameplay prototype that we're aiming for is that we want an AI adversary character, an opponent that we can play against that's as effective as possible, basically as strong as we possibly can make it, but not being cheap about it. And what this means is that this AI character is going to have access to all the same gameplay abilities that we have. So this episode is the start of that. We are integrating our gameplay ability system with the AI character. And it's important to note that this episode is heavily reliant on past episodes, so you will not be able to copy the setup of this episode unless you've really been following along with this series. But I figure at this point in the series, we are well past the basics, and it's about time that we pivot and start aiming for gameplay. So here are the key concepts for this episode, and I gotta apologize ahead of time, guys, because a lot of this episode is troubleshooting. Part of it is that I want you to learn troubleshooting as we go along in this series because it's absolutely essential to everything that you're doing. But the truth is that it's only often after the fact that I realized that I should have done something a slightly different way. And an example of this is when we set up our gameplay abilities, I set them to point to our player character rather than the owning actor, rather than the actor that actually possesses those abilities. So we'll get that fixed this episode. And truth be told, we are now in the trenches. We are learning this process together, and everything we'll do in this series, if I mess it up, which almost always I do, we're going to fix it together. Onward and upward. So let's get to it. Alright, so to start today, we have to set up the capacity for our AI character here to be able to receive abilities. So to do that, we're going to open up two different things, our AI adversary controller and also our MyPlayerController that we started all the way back in our gameplay ability UI episodes. So I think this was episode 32, we'll open that one up. And then also under AI, this was episode 48, AdversaryAIController. So if we go back to the MyPlayerController, so the player has both an ability hotbar and an inventory. And our AI, it's going to be a little bit simpler because it only needs one list. It only needs one list of abilities that it can activate at any given point in time. It doesn't need to toggle between a hotbar and an inventory. So for us, that's just going to be the hotbar. So we're going to start by copying our gameplay ability hotbar from our MyPlayerController over to our AI. So paste variable. And the one other variable we're going to need from MyPlayerController is under gameplay ability UI here, this empty hotbar slot. We'll just copy that and paste it right back over. Right click on variables, paste variable. Make sure you don't paste in our local variable here. So compile and save your AdversaryAIController, and then we have to copy and paste some functions from the MyPlayerController over to our adversary. So I'll start over here. And make sure to paste these in this order I'm going to show you because otherwise you might run into some issues. So the first thing, gameplay ability intensity boost, copy that over to AdversaryAIController, and then right click on functions, paste function. Keep the name exactly the same. I wish we could do inherited functions for these, but the problem is our controller, our AI controller, is fundamentally different than a player controller. Then we go back over to MyPlayerController, and the next function we need is this already has ability check. So we'll copy that, back over, right click on functions, paste that. That one we're going to have to update a little bit, but before that, let's go back to MyPlayerController. We'll get the two last functions we need, and these are both under gameplay ability UI. So we got to get the find empty hotbar slot there, copy that, back over, paste function. In the last one, back to MyPlayerController, we got to pick up ability on hotbar. So copy that, and back over, and paste. And we don't need any other functions here because the rest of our functions, it's either hotbar to inventory stuff or inventory back to hotbar or moving our ability and image. There's no UI for our AI, so we don't need that. So back to our AdversaryAIController. Let's clean up the four functions we've got. So the first one is the pickup ability on hotbar. So the second part of this is all related to our UI. We don't need that, so we could delete those out. Delete these out. We just need this part here. Compile and save that. And when you compile that, it gets an error. And the error has to do with the next thing we have to solve, which is on our already has ability check here. And it's saying here that our gameplay ability inventory, that doesn't exist. And that doesn't exist here because we do not need an inventory. So we can delete this out. We can also delete out this branch and the return node up here. So the point is with this function, when it's finding whether or not we already have the ability, it's just checking our hotbar only. And then when completed, it does this. So make sure your completed function now looks like this. You should have everything that we set up in the gameplay ability UI episodes, just without the inventory piece. And if you can compile and save your AdversaryAIController, you're in good shape. Alright, so our gameplay abilities for our AI are going to be stored on our AdversaryAIController. So our controller is all set, but we still haven't told our AI character how to pick up those abilities. So that's the next piece that we're going to set up now. So let's go back to our content drawer. Let's open up our actual Adversary AI character. And then we also need to open up, obviously, our third person character, which is where we can currently pick up our abilities. So on the event graph of our third person character, so back in episode 53, we consolidated this down to a single function, attempt to pick up ability. But if we go into this attempt to pick up ability, this is doing all sorts of crazy stuff. Like it's checking to see, do we have the ability already? And if not, do we pick it up on our hotbar? And if we don't have room on our hotbar, then it picks it up on the inventory. So for our AI character, we don't need all of this. It's going to be a lot simpler, but we do need this overall function. We just need to clean it up a bit. So the easiest way we can get the gist of the function, but then change it up, is we can override the function on our Adversary AI character. And the reason we can do that is our Adversary AI character, the parent class, is the third person character. So by default, it gets all the functions that our third person character has. So the way I can see this is if I go to class settings, then I can see the parent class right up here is our third person character. So back to class defaults. So what we're going to do under our Adversary AI character, under functions here, we can override functions. And we're going to override the attempt to pick up ability function. And by default, when we override, it's doing what the parent's already doing. So it's adding on to what the parent's doing, which is all this stuff. We don't want to do that. We want to actually override it. So I'm going to delete this out. And then I can go back to our third person character and we can copy all this stuff and we're going to paste it in, but then we're just going to clean it up a ton. So make sure the purple node is to the left here and we can connect up our gameplay ability right here, gameplay ability pickup right here. I'm going to zoom out because the very first thing that we're going to eliminate is this attempt to pick up ability on inventory. We won't need that. So I can cut this entire piece. I can also delete out the destroy actor. We're not going to need that because we're basically going to expand the hotbar as long as it needs to get in order to pick up abilities. And that means for this attempt to pick up ability on hotbar, we don't need to do this hotbar check because our hotbar is going to be infinitely sized for our AI. It's just going to get longer and longer past 10 abilities if necessary. We're not at that point right now because we only have 4 abilities on our game. But regardless, I'm going to delete out these 3 nodes right here and connect up the false here directly to this. But now we've got to do something that's kind of tricky, so pay attention to this very closely. So this PlayerController reference, this is what's referencing our functions here. And we need to switch this out with our AI controller reference, and that means we need to actually get new functions. So we can pull in a reference to our AI controller, and we can reference the same functions because we just copied and pasted them from our PlayerController over to our AI adversary controller. So we could search for already has ability check, and you're not going to be able to just connect it up like this because the target is my PlayerController here. So we're actually going to have to delete this out, but let's set everything up before we do that. So let's connect this up here. Let's connect up our execution pin up here, this to the branch here, and then match found here, and then this gameplay ability match up to this. Very easy to miss one of these nodes, so look very closely. Delete this out, move this down. And we've got 2 other places in this overall function where we have the same thing. So up here, PlayerController reference. Once again, we've got to get a reference to our AI controller. And then we could do gameplay ability intensity boost, just like that. Connect up all the same things in the same way. So the branch up here, gameplay ability to gameplay ability, the output here, and then the execution pin here. And then we can delete out this one, the bottom one, PlayerController reference as well. All right, 2 down, 1 to go. So we got to move down here, pick up ability on hotbar. So the first thing is I'm going to move in this comment, same kind of thing, AI controller reference, and then drag out pick up ability on hotbar. Connect up this to gameplay ability pickup, connect up this here, and then over here on the left, connect up the false branch right here. Delete this one out, move this one down, PlayerController reference, delete that out, AI controller reference right there. All right, let me zoom out, make sure you got all that. So all the stuff at the end, we can leave exactly the same because that's just affecting the Niagara system on the pickup effect and setting it to be no collision, inert. And we're actually going to add something onto this by the end of the episode, but you'll see. And make sure you've got everything else set up with your AI controller references instead of your PlayerController references. Okay, compile and save. And if everything compiles, so far so good. So the next thing is we have to go back over to our event graph. And I already still have this event pickup ability that when we started the AI character, we had that. But if you don't have that, that's okay. So you can just right click and search for event pickup ability and you should be able to pull it in. Because that pickup ability interface we set up on our third person character under here, under interfaces, pickup ability, and because our adversary AI character inherits from third person character, then we have all the same interfaces. So once you get this event pickup ability, very simple. So what we just overrode, the attempt to pick up ability, so we can drag that in, connect this up here, connect this up here, connect this up here. And then I'll put in a short comment and just say ability pickup. So now our AI character has the capacity to pick up abilities, and now we just need to figure out how to change its behavior so it actually wants to pick up abilities. But before we address that question, I want to do a quick recap on all of our AI behavior set up from previous episodes. So this is the current state of our behavior tree, BT Adversary AI. Basically, what we've got right now is if our AI has line of sight to target and the target is always our player, then it checks, okay, is the target in air or is it not in air? And that's based on the speed and jump boost ability where our player could just be floating in midair. And so this right here, this is going to work well for our player, but not so well for gameplay abilities. Like we want the gameplay ability to be able to be reached. For the player as a target, it doesn't need to be reached, it just needs to be able to be seen so that our AI can actually target and throw a fireball, flamethrower, whatever it might be. And then we're checking to see, okay, has our AI recently detected the target? And if so, then move to that most recently detected target location. And that's useful, for example, when our player is heard and the AI can then move to that heard location. And if it doesn't have a last known target location, then it just selects a patrol location and moves to that location. So to make our AI character be able to aim for and then pick up a gameplay ability pickup actor, all we really need to do, the simplest possible thing, is just set our gameplay ability pickup actor as the current target. And then it could just move to that location and pick up the gameplay ability, right? But that's not going to cut it long term because realistically, our AI needs to be able to track different kinds of actors on a revolving basis. So it needs to be able to differentiate, okay, is this a character? Is this an enemy character? And if so, I'm going to treat that differently than, say, a gameplay ability pickup actor. And there's lots of other things that it's going to need to be able to track. So for example, if a fireball is heading straight for it, it needs to recognize that as a threat and be able to move out of the way. And what this boils down to is really, depending on the situation, the AI needs to identify what its priorities are at that particular moment in time and reprioritize accordingly. So really, the fundamental question that we're trying to begin to answer this episode is, at this moment in time, what should our AI's goal be? Like, what should its target be? Or another way of framing the question might be, how does the AI pick a particular goal based on the current state of the game? And we're not going to solve this question this episode, because this is literally the mountain that we are starting to climb right here, right now. And even further, this question that we're beginning to address this episode, this really is the question of our time. Like, how do you make an AI realistic? Whether it's a realistic conversation partner, a realistic artist, or in our case, a realistic opponent. And I have some ideas, but I am the furthest thing from a cognitive scientist. So along the way, if I'm going down a wrong path, if I'm messing something up, if I'm doing something that's just flat out not going to work for AI, please let me know in the comments below. And your feedback as part of this process is going to be tremendously helpful to calibrate and ultimately make the most realistic AI that we possibly can. So to begin tackling this problem, I've come up with what I think is the simplest possible model to conceptualize AI behavior. And when I'm thinking about this, the best model for how we want AI to behave, it really comes from the natural world. When we're thinking about realistic AI behavior, we're really thinking about realistic behavior for all organisms. And I am the furthest thing from a biologist. I keep saying this, but I'm doing the best I can here, guys, but I've organized behavior into these 4 quadrants. It's the simplest possible way that I can understand all biological behavior. Every single organism on this planet, every single living being has mechanisms for safety and threat detection. Even the smallest single-cell organisms like bacteria, they can still detect whether something is too hot or too cold and move closer to it or move away from it accordingly. And every single organism has to acquire resources in order to survive. Every single organism has to explore to find those resources. And every single organism needs to engage in some capacity with other organisms of its own kind, but also other organisms of other kinds. So how does this diagram even relate to our AI that we're beginning to set up? In short, what we're going to do is we're going to set up modes of behavior. At any current moment in time, our AI could be in exploration mode, looking for stuff. Or if our AI has a target, an acquisition that it wants to acquire, then it could be in acquisition mode. And at any given moment in time, some form of threat detection might change our AI's mode into safety mode, like trying to dodge an attack. And basically, this episode and every subsequent episode is going to focus on a different mode of behavior, or at least how do we get the AI acting properly within a certain mode of behavior. And once we're in a solid spot with each individual mode of behavior, then we can begin the complex process of how do we bring all those modes together in creating complex AI behavior. And this brings us to the question of time, because as we're designing this now, I'm conceptualizing this circle here as short term, i.e. what the AI should be doing right now. But for the AI to be a truly effective opponent, it's going to need to be able to plan plan ahead. It's going to have a strategy, at least for the medium term. So for example, maybe the AI recognizes that at this moment in time, it's got fewer gameplay abilities compared to its opponent, or its gameplay abilities are not as strong as its opponents. And so the AI needs to plan ahead and say, okay, I'm not going to engage now. I'm going to wait until I pick up more abilities so that I have an advantage, and then I'm going to engage with the opponent. But maybe the AI can throw fireballs at me while it's acquiring other abilities. So it has to have both short-term and medium-term goals. Now for long-term goals, will the AI be able to study its opponent and learn from its opponent over time? I have no idea. But just to put this out there, that's one of my long-term goals. But to bring us back down to earth, to bring us back down to the here and now, we are going to create the structure in this episode for AI's short-term behavior. We're not going to yet be at the point where the AI can switch between modes, but with any given keyboard shortcut, we could switch the AI ourselves into a mode and make sure that it behaves accordingly. Now, in previous episodes, we've already got the AI basically doing exploratory behavior. Now, it's only looking for the player at this point, but that's going to change. With this episode specifically, the AI is going to be identifying gameplay abilities to acquire and then move toward and acquire those abilities. And that's going to set us up for the next episode where we'll be talking about how does the AI determine which ability to use depending on the tactical circumstances relative to its opponent, relative to the player. So we're going to start this process very similar to what we did in episode 26, and that is we are going to create an enum. So back in our AI folder, I'm going to right-click Blueprints Enumeration, and I'm going to call this AI mode, and we'll go into that. And in the description here, I'm just going to put in modes of AI behavior. So then we'll add an enumerator. First one is going to be safety, safety first, or third. I always forget. Second one's going to be exploration, then acquisition, and then aggression. And I changed assertion to aggression here because with organisms, they're doing all sorts of behavior relative to other organisms. But in our case, it's going to be purely aggressive, at least for now. I'm going to add another enumerator. This one's going to be follow player. And this last one, this fifth one, doesn't really fit into my model, but it's a good idea to have a follow player option. So we'll save the enum, close this, and we'll go into our AdversaryAIController. We'll do a new variable, and we'll call this the short-term mode. And it's going to be of type AI mode, which is our enum. And then in the event graph, if I go back to the event graph, I've got too many functions open. Just going to close out of these. Event graph, and then on event begin play. So up here, event on possess for AI. Then we are going to set our short-term mode to acquisition. And it's going to be set to something else in the future, but just for the purpose of testing this right now, set it to acquisition. So let's compile and save this. And the first thing is, let's place our AI nice and close to some GameplayAbilityPickup actors. So I'm going to take our AI actor, and feel free to drag it into the world if you don't have one in the world already. And I'll move it over to the two gameplay ability actors we set up in episode, was it 58? No, 57. And the first thing is, let's check to see if the AI can even see these actors, right? So if I go back to AdversaryAIController, and I move out some space here from AI perception site, what we can do is a print string just to see what our AI is seeing at any given moment in time. So get display name here, compile and save. And then let's do a simulate. So our AI is not seeing the actors, right? It's not seeing anything. It's just running around, headless chicken, into the ocean. So by default, AI characters perceive other characters, but not random actors. And in order to perceive random actors or actors that we create, we need to add what's called a PerceptionStimuliSource Component to those actors. So if you select any of your GameplayAbilityPickup actors, and we go into that. So we're going to go to add here and search for AI Perception Stimuli Source. And there's a couple of things we need to change on this component. So on the right-hand side, we need to auto-register as source, and a plus sign here, and we need to register it specifically for our AI Sense site. And I suppose in the future we could also register this for AI Sense hearing, but right now our GameplayAbilityPickup actors are not making any sound, so we'll keep it site for now. I think that'll be fine. And there's one other obscure thing we got to set here, and this drove me nuts trying to figure out, but what we got to do is for our pickup collision sphere right here, we have to come down in the details panel, and under our collision presets, instead of overlap all dynamic. So what was driving me nuts as I was testing this out is that our AI character was seeing those gameplay ability actors, but then when they were running towards it, they just lost sight and they started running at something else. And I realized that function that we set up in episode 49 that reestablishes visual contact periodically, it wasn't working with our GameplayAbilityPickup actor here. And the reason was that it uses camera trace collision, very obscure. And right now it's overlap all dynamic, including camera trace collision. So we got to change this over from overlap all dynamic to custom, and then just the camera channel, we'll change it to block. So we'll compile and save this. And then what we want to test is whether our AI character actually sees both of these. So we'll simulate, and then, yep, GameplayAbilityPickup, pickup 2. So we're seeing those print in the top left corner. Now the AI isn't yet running at them because we haven't set them as targets, but let's do that next. First thing is we need to give our AI a mechanism by which it can identify our GameplayAbilityPickup actors as something it wants to acquire, so something other than a character. And so the way I'm going to do that, if I go back into the GameplayAbilityPickup actor and select self up here, so then we're going to search for tag. We've done tags in previous episodes, and we'll add a tag of acquisition. It's just like the 9th rule of acquisition, guys. So now let's set our GameplayAbilityPickup actors to be the target that our AI actually wants to run towards. So we'll compile and save our GameplayAbilityPickup actor. We're done here. We can close out of this. And we're also done with the PlayerController and our ThirdPerson_Character, I believe. So we'll close out of both of those. Back in our AdversaryAIController. So we can delete out our print string, get display name. We won't need that. And this is where our short-term mode, enum, is going to come in handy. So we'll drag in a reference to short-term mode, get, and then we will do a switch on AI mode. Connect this up. So basically the way this is going to work is on target perception updated. If we're currently in the acquisition mode, then it's going to run at that target. So I'm going to rearrange this stuff just a little bit. So we're going to take our current target, we're going to move it over here next to our branch. Connect it up here, connect this up here, put in a little reroute. And what I'm going to do, just to make some space, zoom out, move these up. We're going to collapse this stuff to a function, but for now it's going to be a little bit messy, so we need the space. So I'm going to move both of these down. We got to duplicate all of these, copy and paste, and then we can connect up our actor here, and the tag is going to be acquisition. And we got to move this branch down here, and this follow player is going to go to this branch. And then we're going to do another branch. So from acquisition, we'll do a branch from here, and that's going to be hooked up to this, true hooked up to here. I know this is messy. So the way this is looking right now is if our short-term mode is acquisition and the actor that is sensed has a tag of acquisition and it's successfully sensed, then it's going to set what it sensed, the actor, as our current target. And if our short-term mode is follow player, then it's going to do the same if the actor has a tag of player. And I just tried compiling and saving, and I forgot to hook up my AI stimulus, so make sure you do that. So compile and save this, and once that successfully compiles, then you don't even need to put your character into the world. We can just simulate. And look at that. He's running at our gameplay abilities. He's picking them up. But when I stop simulating, woo, all sorts of errors. So what's going on here? Well, the very first thing is that our gameplay abilities, I mentioned this on the intro, our gameplay abilities, when we set them up initially, I set them all to have references to our player character, which we don't have in simulation mode, instead of the character that's actually picking up those abilities. So the first thing is we got to go back to our gameplay ability pickup actor. I closed out of that too soon. Let's go back into that. And let's make a little bit of space here. So we are on the spawn gameplay ability function because we need to expand this right here. We need to make sure that the owner and the instigator pins are both present. Because what I'm going to do is I'm going to add an input to the spawn gameplay ability here. And the input's going to be who's actually picking up the ability. And that's going to be the owner of the ability. And that's going to be of type pawn. So select pawn down here. And so the owner, we're going to attach up to the owner here. Let me put in a reroute. And we're also going to attach it to the instigator fields. And the instigator basically specifies who has responsibility over that actor. It says pawn responsible for damage and other gameplay events caused by this actor. So we'll compile and save this. And then the one other thing we have to do is on the event graph. So now we have the spawn gameplay ability here with the owner pin. So we got to take our other actor here and connect it up to the owner, but we can't because actors are not necessarily pawns. So what we got to do is an intermediate step. You probably know how this goes. We're going to cast to pawn, and that's going to allow us to verify that in fact it is a pawn. Connect this up here, and if it fails, that just means something other than a pawn is crossing into our gameplay ability actor. And this right here is doing pretty much the same thing. Does it implement the interface? This was our mechanism to ensure that if a bird flew through the gameplay ability actor, we don't have any birds yet, but we will have birds. If a bird flies through the gameplay ability actor, that the bird doesn't suddenly pick up a flamethrower. Though that would be interesting. So now that we actually have an owner of the gameplay ability, then what we can do is we can go back to our content drawer, content, over to blueprints, over into our gameplay ability folder, and open up our parent gameplay ability class. So on the event graph of our parent gameplay ability, we have our third person character reference and ABP third person character reference. This is where I messed up. But actually, if it was only your player character that wanted access to these abilities, then you're fine. Then you could keep these exactly the way they are. But for what we're doing for the prototype of gameplay that we're making, I want all of the AI characters to be able to use these abilities. So we're going to change this a little bit. So I'm going to expand our references here. I'm just going to rename these functions. Rename, instead of third person character, it's just going to be the owner character ref. And same thing for the ABP. So ABP, it's going to be owner character ref. So we'll go into the first function, owner character ref, and instead of getting the player character, very simple, we can just get owner, and the owner is the owner of this gameplay ability, and then connect this up here. We could still cast to a third person character and get our reference here. But then over here, I'm going to rename these variables as well. So instead of third person character reference, it's going to be our owner character reference. And instead of ABP third person character reference rename, it's going to be our owner character reference. Compile and save this, and we'll go back to our event graph and into ABP owner character ref. And I spelled that wrong, so let me adjust that, rename R, and same kind of thing here. So instead of get player character, cut that out, and then we will get the owner. But we can't connect up the owner here right away because we first have to verify, is it a third person character? So cast to third person character, verify that it is a third person character, in which case it will have a mesh. So we can connect it up here, put the mesh up here, connect this up just like that. 1, 2, 3, ABC, compile and save. So we are ready to test again. Hopefully most of these errors will be gone, but there will still be some. But before we test, let's do one thing. So over on our AdversaryAIController, let's go into the pickup ability on hotbar function, and let's actually watch our gameplay ability array here. Let's make sure that the gameplay abilities are actually going into this array as our AI character is picking up those abilities. So if you right click on the word there, sometimes I get it, sometimes I don't. If you right click on the edge, you don't get it, but if you right click on the word, then you get it, and you can watch this value. Okay, so I'm going to make this into a small window. And then we can hit simulate, and I'm just going to change up here, change our debug object to our AdversaryAIController. And as it runs over those abilities, yep, we've got our gameplay abilities showing up there. It's getting cut off because the window is too small, but it is in there. Gameplay ability fire. And our AI is nice and pixelated. Seems to be having a difficult time there. So let's stop simulating. And no more errors, surprisingly. But the reason the AI was kind of spasming out there is after the AI picked up the ability, it's still recognizing the ability there as something that wants to be picked up. So after the ability is picked up, what I'm going to do is I'm going to add a second tag to the ability, and I'm going to label it inert, and that way the AI can know to ignore inert acquisitions. So we'll expand this. We'll go back to our AdversaryAICharacter into the attempt to pick up ability function, and we'll come back over here because this is all the stuff that happens after our ability is picked up. So what we're going to do is we need to get a reference to the pickup actor, which is over here. So this right here, I'm going to move this down just a little bit, and from here we can actually get our tags. Or actually, I'm going to set tags there, put in another reroute just for funsies, connect this up here. And from the tags, we can make an array. We've done this before. Move this out just a little bit. And the array is going to be acquisition as the first tag, and then the second tag is going to be inert, I-N-E-R-T. Compile and save this. And what I realized, and I don't have this in my notes, but what I realized is we also need to do this for gameplay abilities where our character picks those up, because we don't want the AI character thinking they can pick up an ability that has already been picked up. Now, in a future episode, we're going to have a mechanism for taking the ability, moving it to a different location, and sort of like respawning it so that it can be picked up with a different ability in the future. And that's going to tie directly into how our game is actually going to play. But for now, what I'm going to do is I'm going to copy all of these. We have to go back to our third-person character blueprint because we got to put those into the same function. Can't do it just here because we overrode it on our AdversaryAICharacter. So on the event graph here in our third-person character, we can come down to where we're picking up the ability. And then over here, we can do the same thing. So connect it up just like this. Take this node over here, connect it up right over here. Compile and save here. All right, I think we actually are done with our third-person character now. I'm closing that out. We're going to go back to our AdversaryAIController because we can use that inert tag to specify, okay, don't try to pick up this ability if it's inert. So back to the event graph. So we're going to drag down these three and this branch node a little bit more. Drag down this one. We're going to duplicate our actor as tag acquisition, and we're going to set this to be inert, but we want to make sure it's not inert. So we do a not Boolean up here. Add a pin here and connect that up as a third criteria. Actually, I'm just going to switch the order of these criteria so that they're not too confusing. They are already confusing. I'm going to put the not right up here. Make sure to take your actor as tag here, hook up actor to there. That's a lot of spaghetti. Don't worry, we're going to fix that by the end of the episode. Compile and save. And for this test, I'm actually going to get our behavior tree up and running so I can watch him in action. So BT Adversary AI will go into that. And again, make this a small window. I would actually typically do this on a second screen, but this way we'll be able to see it. And right click, play from here. So target is not in there, boom, picks it up, and then where is he going? So then he's patrolling, so that's good, because he didn't see the second ability, but now he sees it. And there he goes. So we also need him to clear his current target the moment he picks up an ability. So let's adjust that. So the way we're going to do that is back in our BP Adversary AI character. So right after we set our tags for acquisition and inert. So luckily we already have functions for resetting our target on our AI controller. So we got to get a reference to AI controller. And from there we can clear a sensed target and then hook that up here. And the other one we need to do is clear recently detected. Clear recently, that one. But I found there's also two other things we need to reset. So we have a current target variable on our character here, but then also on our adversary AI controller, we also have a current target variable. And whenever I try to get a reference to the current target from our controller, so let me show you what happens. So current target and then set current target, and I always pick this one. So we're gonna change that just so that I stop mixing them up. So this one, we're gonna rename, it's gonna be current target car, and we've got a current target on our adversary AI controller. And the controller is really the important one, because that's where our blackboard is actually looking for our behavior tree. So what we're going to do here is we're just going to get a reference to this. We're going to set it to blank. So no current target once we pick up a gameplay ability. And then from our AI controller, we can also drag out a reference and get a reference to current target, set, and set it to blank as well. So connect this up here, connect this one here. Compile and save this, and we'll test it one more time so we can make it small in a window. So our AI is running, picks up the ability, yep, resets the target instantly, picks up the ability, and he's back to patrol mode. So far, so good. So now let's give our AI the capability of attacking. And it's not going to be smart enough to actually switch between attacks or even go from one mode to another mode, like switch from acquisition to aggression, but that's okay. The first thing that we got to start out with is just making sure that everything in regard to the attack itself works. And that's stuff like the animation, it's the gameplay abilities, so let's set that up. So now we got to go back to our third person character because that's where we're going to trigger this to actually occur. So back in our event graph, come down to the bottom. I always do the letter U, so let's stick with that. Keyboard U. And when U is pressed, we are going to get actor of class. And the actor of class we're going to get is our BP Adversary AI character, this one. Connect this up. And from here, we are going to get AI controller. And from there, we're going to cast to our adversary AI controller. And everything we're doing here, it's temporary. It's just the simplest possible test to get attacking up and running. From our adversary AI controller, we have to get our gameplay ability actors. So gameplay ability hotbar. And then for each of these, so for each loop with break, we could do a random one, but let's just do the first one that our AI picks up. So from loop body, we are going to activate the ability, and then we'll connect this up here. And then when we activate the ability, then it's going to break, and it's not going to even try activating anything else. Compile and save, simplest possible test, just to make sure the abilities are actually working. And we're going to run into trouble, but we'll fix it. All right, our AI's got an ability, let's do it. And the fireball is stuck to the hand. Nothing goes. And not only that, we get these errors right here. Set slot activated, restore hotbar button to default. And where that's coming from is this right here, because this is a function that's called on our third person character blueprint, restoring our hotbar button to default, and we don't have any buttons on our AI character. So very simple fix for this. So we're going to go back to our BP adversary AI character, and under functions here, we're going to override that one too. So we'll come down, 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 restore hotbar button to default, and I'm just going to get rid of the parent reference, and this is going to do absolutely nothing. Compile and save. And we're going to do the same thing with one other function. So we're going to override, and this one's going to be the activate hotbar button. Same exact thing. Delete out this, compile and save. And then let's test again. All right, he's got a couple of abilities, and here we go. U, and nothing. But when I exit out, no errors. So we still have the issue of the fact that the ability is not actually activating, right? So we saw the start of a Niagara system with the fireball, but nothing's actually going. And why is that? And the reason is, I'll show you why that is. So in our content drawer, I basically had to trace out this logic all with print strings. And step by step, I just went everything from activating the ability to the gameplay ability fire, all the way down. and nothing was showing up as the problem. But the problem is all of our gameplay abilities are actually originating from our animation blueprint. So if we go into the animation blueprint, it's specifically, if we go to the event graph and then come down here, it's this anim notify activate main ability effect. And what's going on is it's getting to this right here, our activated gameplay ability, and it's not valid. And the way you could figure that out is, once again, you could right click on here and you could watch this value. So we just need to make sure that we have our activated gameplay ability when we press U. So back to our BP third person character, back to the event graph. So we can't just set our activated gameplay ability here. What we have to do is we have to come back to our actor of class over here. And from here, we can set our activated gameplay ability, because otherwise we're setting it on the third person character and we're not setting it on our AI adversary character. That's why I needed to come back here. We're going to fix all this in future episodes, but just to get the test up and running, connect this up here, and then connect this up here. For each loop with break, connect your ability up to what's activated. So compile and save this, and then hopefully, maybe, our final test. All right, he's got one ability, and yep, now he sees the second. And we hear the effect. That's a good sign. And moment of truth, you. Yep, we got fireballs. Now he's not aiming yet. That's what we're going to do next episode. And actually, the fireball has collision, so that's a good sign too. So the next thing is, let's test with all three abilities, right? So what I'm going to do is I'm going to copy and paste the fireball. He's always picking up the fireball first, so I'm just going to change the fireball here over to a different gameplay ability. So over in our details panel, I'm going to switch this from fireball pickup to air. Actually, I think it's small cloud. Yeah, small cloud base ability icon. That's not really going to matter for our AI, but we're going to do it anyway. So search for air ability channel. Ability type is air. Intensity is 100. We're going to do our air ability with UP, air channel with UP. And how gameplay ability is used is channel. Let's test it again. And you. And he's running like crazy and jerking around like crazy and getting hurt in the process. So let's see if we could fix that for our air ability so that he's not, spinning around all of a sudden in a single tick. So what we're going to do to fix that, if we go back into our adversary AI character, it's actually got a really quick fix. And there's a link in the description below, a website I found on this, how to smoothly rotate characters, worked perfectly. So we're going to select the very top actor here and then search for rotation. And we're going to change two things here. So we're going to set the rotation rate Z to 180. And this is what the guy on the website recommended, but it worked great for me. And then the other change is this use controller rotation yaw. We're not going to set that. So we're going to keep orient rotation of movement. So we'll compile and save this, and then let's test again. Play from here. So now he's suddenly decelerating very quickly, and we'll address that in the future. But another problem is he's just jumping around like crazy, not going anywhere. And the reason he's doing that is because I've got a gameplay ability up in the air that is nigh unreachable, but he doesn't know what to do. He's just jumping up, not changing direction. And that's his current target, but it's not in the navigatable radius. So let's fix that too. So for that fix, we're going to go back to our AdversaryAIController. And on our event graph here, we have to add one more criteria to our acquisition here. So I'll hit plus sign and I'll connect successfully sensed here, disconnect it here by holding Alt. And again, I'm going to create more space, move these down, move this one down. And there's a really neat node that we can use to identify whether or not a particular point, whether or not a particular location is actually reachable. And so we're going to get our stimulus location, drag out a pin, and we are going to project point to navigation. That right there, and then connect up whether it returns true to this. Because if it returns true, then we can navigate to that point. But if it doesn't return true, then this is going to be false and it's not going to update our current target. Compile and save this, and we'll do another test. And you want to check to see, is he jumping around, spasming, going to an unreachable target? So right now he's just patrolling around because he doesn't see the abilities. But once he sees the abilities that are reachable, like the flamethrower, he should get it. Yeah. But he's no longer jumping around. Now the next problem is he arbitrarily runs into the ocean, and the ocean is going to be a kill zone in what we're designing. So we don't want our AI character going into the ocean, if at all possible. So how do we handle that? So to solve this, I think the best way to do it is when we actually pick a patrol location. check to see if that location is under the water. Because if it's on land under the water, we don't want our AI moving in that location to patrol. So what I'm going to do is back in our content drawer, AI folder, in the BT tasks folder, we created this BT task select patrol location. So we'll go into that and we're going to create a brand new function here. So we'll do a plus sign and we'll name this select new patrol location. And the reason we're creating a new function is so that if the patrol location is under the water, then it's going to call this function again. It's going to do basically set timer for next tick, and then it's going to get a new random patrol location. So we're going to start in this function by creating a new local variable. So plus sign here, we're going to call it the local reachable, and this is going to be a Boolean. And then we need to create two variables outside of the function. So two variables on the core blueprint itself. And the first one is going to be the original location. And this is the location by which we're getting our actor's position, our AI character's position. And that's going to be a vector. And then our second variable is going to be titled random location. And this is going to be the random location that we get from that original position. And so the way this function is going to start, so we're going to get our original location. And from that original location, we are going to get a random reachable point in radius. So basically, we're replacing this. But let's go back to the function. So the radius is going to be our patrol radius, get patrol radius. And this random location here is going to set our random location here. So connect this up here, connect this up just like this. And then we're also going to set our local reachable value. And this is going to be connected up here, this to here. All right, so this is going to check, was it a reachable location? And then we're going to branch from there. Now, I don't know the circumstances in which this would be false, but if it is false, we're going to do a return node. And on the return node, we are going to add an output. And the output is simply going to be, is it reachable? So we're going to take our local reachable value, do a get, and connect that up. And in this case, this false pin, it would be no, because no from here would go to here, and then it connects up here. But typically it would be yes, and then we have to check, okay, is that position within water? Like, is it in the ocean? And I thought about narrowing this down to just the ocean, but I think we want our AI steering clear of water generally, because it's going to slow down our character. So from the true here, we are going to do a line trace by profile. We've done this a lot for water. But what's unique about this is we're going to get our random location that we're setting right here, get, and we are going to add a very high value. So we're going to add about 2,000 units up. 2000Z. And this is going to ensure that the line trace always starts well above where our water is, even in really deep water. So then connect this up here. And I suppose if you have a really steep cliff that's like 10,000 units below, then you would need to make this even higher, but I don't. So we'll move this plus sign over, and then it's going to go to, let's go just a few units below the location. So let's do minus 300. And the Z is actually 300 here. I just did a minus vector. And then once again, as we've done in previous episodes, we got to tell it our actors to ignore. So we did this back in episode 60, where we can get our water body ocean. And then from there, we can connect that up just like this. It automatically makes an array. I don't know how to store this value in such a way that it doesn't need to be called every single time this kind of blueprint, this kind of task gets called. But if anyone knows a more efficient way of doing this such that we don't need to call this function every single time the task gets called, please post in the comments below. And then from our line trace by profile return value, we're going to add a branch, connect that up. From our out hit, we are going to break the hit result. And we've done this many times before as well. So from physical material, we're going to check to see, is that equal to water underscore PM, physical material? If this is true, then we're going to do another branch and we're going to check to see, okay, when we get a hit, is that water? Because if it is water, then we're going to set our local reachable to false. So we're going to set this to false. And then once again, we can get our return node that's over here and we can copy and paste that at the end and connect this up. And then we're going to connect up our false the same way, connect up this false the same way. So just to trace through this logic. So what this function is going to do when called, it's going to get our original location. Now we haven't set this yet. We're going to have to set this back on our event graph here. And it's going to get our patrol radius, which right now is 1,000. Let's boost this quite a bit. Let's set this to 5,000. So our AI actually moves pretty far out. It gets a random reachable point from that location, sets a random location, and then it checks to see, is it reachable? If no, then it returns that it's not reachable. And it's going to do something on our event graph if it's not reachable. You'll see. And then true, it does a line trace by profile straight down. So 2,000 units above where that random location was. So that's about 20 meters above, and then straight down. And it goes a little bit lower so that it actually hits the water or whatever is below our target. It ignores the ocean, but then it checks to see, okay, what it hit. Was the physical material it hit water? If true, it says, nope, this is not a reachable location, returns that. And if false, then it goes right here, and presumably it's going to have the same local reachable true value from this originally, and that's going to be returned right here. So if it hits anything other than water, we're good. And in the future, if we have something like lava or something else, we could just expand this list right here. I don't want to give away my hand too much with the lava. Okay, let's go back to the event graph. So what we have to do now, we can delete out all of this because in effect, we've got our function to replace all of that. So I'm going to pull in our select new patrol location. I'm going to move these three out, connect this up just like this. Now, if it's reachable, then it goes here. Connect this up. Now, if it's not reachable, what I want to do is I want to call that very same function next tick. But instead of doing that, we're going to do set timer by function. No, we're going to do set timer for next tick by function name. I use this a lot. I haven't seen a lot of people use this, but I think it's so useful. So connect up the false, drag these both out. The function name, we got to get that verbatim. So I rename and then paste it. And so it finishes the task, but it's going to call that same function again next tick. And that's going to get a new random location right here. But it's still going to be based on our original location. And we have to set this back in the event graph. So let's go back to our event graph. And what we got to do is we got to get our controlled pawn here and get actor location. If I could spell, that'd be helpful. Get actor location. And I'm going to move these three out a little bit more because we have to set our original location. Connect this up here, connect this up here, connect this up here. So the last thing we got here is we've got a dangling vector reference that we have to tell it our current movement goal location without a target. That's our patrol location. So that's going to be our random location here. Get and connect this up. And we can delete out this reroute. So if you've got all that, so make sure you're setting your original location based on the control pawn actor location. We have this function. If it's false, if it's not reachable based on hitting water, then it selects a new patrol location. And the one last thing I'm going to do to test this back in our function, I'm just going to turn on the line trace. So for duration here, and that way we can see it in the world. So compile and save, and let's test this out. I'm going to do a window again just so we could watch. All right, so he's patrolling. And let's see if he goes into the water at any point. So he's moving around and he gets to the water's edge, but he does not go in. And if we check our behavior tree, he's just patrolling because he can't reach our little fireball up there. You might still encounter some strange behavior from time to time as you're testing this out, but like I said on the intro, this is going to be a process. So if you are seeing weird behavior, just post in the comments below and we'll definitely address it in upcoming episodes. But now to finish out the episode, as we always do, cleanup time. So let's start in our third person character. And specifically, let's go into, under gameplay abilities, the overall hotbar ability here. And I know we didn't touch anything with this episode, but 2 episodes ago with the torchlight ability, I was struggling to figure out why does the light need to be repositioned relative to the hand? And the reason for that, I finally figured it out, is that every time we activate an ability, we attach actor to actor here. And I'm going to get rid of this. You could just straight up get rid of this and it should still be working fine. If you want to test it out, we can just go back to that torchlight ability and do a play from here. And this is what I was talking about. When we hit 1, yeah, so we still have the ability and we can crouch and the light's just fine. We still get the shadow of our hand. Everything's good. But then we get to the main event in terms of cleanup. So let's go back to our AdversaryAIController and our event graph on target perception updated. This is all a mess. So we're going to keep this really, really simple. We're going to take all of this stuff here. We are going to collapse it to a single function. This function is going to be a pure function because we're not changing anything in this function. We're just assessing something. And what we're assessing, I'm going to rename the function, is active acquisition scene. If I could spell. There we go. And if I go into that function, we're just going to change this up a little bit. So we don't need 2 pins here. I can delete out the self 3 and take this pin, connect that up there, take all this stuff, we're going to move it underneath. And I'm going to change our input names just so we know what that's doing. So this is our actor, that's scene. And the second one here, this is going to stay our AI stimulus. So compile and save this, but then you'll notice it doesn't compile. We got to go back to our event graph and just hold Alt and delete out that pin and you should be good to go. Now we're going to do the same thing down here. So these 3 right here, right click, collapse to function. This is also going to be a pure function. And I didn't make this connection till many months doing Unreal, but anytime you see a green node in Unreal, that just means a pure function. And pure function, that just means it's not changing anything directly in the function. It's just getting data. And this one we're going to rename to be player scene. Same kind of thing where we'll go into it and I'll just move these 3 down a little bit. Instead of self 2, this is going to be actor. Compile and save that. back to the event graph. Okay, we got our two functions. Just gonna move up our two branch nodes. I'm gonna put in another reroute here so we could put this underneath. And this one over here, that's looking a little bit better, a little bit cleaner. Move these in, move all of these in. Yeah, much, much better. And both of these functions, I'm going to categorize under a category of AI perception, player scene as well, AI perception. Compile and save this. And let's just do one more test after you clean everything up. Just make sure I went out the wrong way. Let's just make sure all of our gameplay abilities can be picked up. And let's start with our flamethrower because we haven't actually tested that. Right about there. Play from here. Looking good. So we get one last error here that you might see, and I just want to show you how to fix this. This activate dynamic force over water. And this is occurring in our fire blueprint, gameplay ability fire blueprint. And it's what we're doing on event tick. So up here, this check and update dynamic force over water. We set this up back in episode 57. And the reason we're running into problems here is because in our third person character blueprint, we go back to our event graph. So on begin play, so all the way up here, set fluid sim dynamic actors. We're doing this in our third person character, but we're not doing it in our adversary AI character. We don't yet have that here. And I actually played with this for quite some time. I tried getting it working on an AI character and straight up, it was not working. So I suspect that this is a limitation right now with fluid sim. AI characters are working fine with 2D water indoors, just not the fluid sim water. And one reason is probably that the fluid sim itself is connected to our third person character. Like there's that little checkbox that says attach to player character, but I was hoping that other characters could still interact with it. So if you're able to get that working, I'd be interested to know more. So feel free to join the Discord. So all we're going to do to fix this, very simple. So on our third person character, right after set fluid sim dynamic actors. So this is on event graph, on event begin play, right here, all the way at the end of this string. There's a function for is player controlled. So this function right here. And we could just call this every time a gameplay ability is spawned, but I think that's more performance intensive than I would like. So make sure you're on third person character, right click promote to variable. And connect this up here. And this variable, we are going to title this PlayerController ? And I'm going to put that under references. Compile and save this. And then once we have that here, so we also have the reference variable now on third person character, we can go over to our adversary AI character and also on event begin play. We can get is player controlled, and we know that this is going to be no, but we can set that same variable. So PlayerController, set PlayerController. And we're not going to have that variable unless you do it on third person character first. So compile and save. And then once we have that variable set on begin play, then what we can do in gameplay ability fire, we can basically say, okay, all the way over here. So when it's about to do stuff with the primary dynamic force component. So it's not going to have that if it's an AI character. So all I'm going to do is from owner character, I'm going to get player controlled, get player controller, and then we're going to connect that up to a branch. Connect this up here, and only if this is true, then do this. And I'm going to move this up a little bit. I'll do a comment. I'm going to say temporary because fluid sim is not working for other characters. I'm crowdsourcing this problem, guys, with this series. And one other quick tip. So something that's temporary like that, I like changing the color of the comment. So you could do that over here on the right. I'm just going to make it kind of a bright red. That way it stands out. So compile and save. And we also got to do this one more time. This activate dynamic force over water over here. So same kind of thing. So we get our owner character and we say player controller and get player controller. We move these three down. And this one we are going to branch, and only if this is true, then we'll connect it up. Compile and save this. So let's test one more time. So we hear it. That's good. The fire's even got collision. Nothing happening to our player yet, and no errors. So that wraps up our episode for today. And in our next episode, we're starting a 3-part mini-series on AI attacking, starting with aiming. So I hope to see you there.